Imagine this. We're on the brink of sending a spacecraft to the most enigmatic and terrifying entities in the cosmos, black holes. These cosmic monsters are shrouded in mystery, and their elusive nature makes them incredibly challenging to study. But what if we could get up close and personal with one of these gravitational giants? That's exactly what one daring astrophysicist is proposing. But here's where it gets controversial. Is it worth the risk? And what could we possibly learn from such a perilous journey? Let's dive in and explore the mind-bending possibilities. Black holes, those ultra-dense, light-swallowing behemoths, have long captivated and confounded scientists. Their intense gravitational pull is so strong that not even light can escape, making them invisible to our telescopes. Instead, we rely on observing their effects on the surrounding spacetime, like a detective piecing together a crime scene from the evidence left behind. But what if we could send a probe to orbit one of these cosmic heavyweights and gather data firsthand? That's the audacious plan put forth by Cosimo Bambi, an astrophysicist at Fudan University in China. I was searching for an entirely new approach to studying black holes, Bambi told Science Alert. And I realized that an interstellar mission to the nearest black hole isn't as far-fetched as it sounds. Yet, surprisingly, no one had ever suggested it before. Black holes are the ultimate cosmic strongmen, boasting the most powerful gravitational fields in the universe. While we've made some headway in understanding their behavior, the truth is, we're still in the dark about most of their secrets. And this is the part most people miss. Black holes offer a unique opportunity to test the limits of general relativity, Einstein's famous theory of gravity. The extreme conditions near a black hole would push the theory to its breaking point, allowing us to probe for any potential cracks in its foundation. In his proposal, Bambi outlines the feasibility of a black hole exploration mission, tackling the first two major hurdles: identifying a suitable target and developing the necessary technology. Now, let's not kid ourselves. This is a long-term plan. Our current tech isn't ready for such a journey, and the distances involved would mean decades of travel. But every epic voyage begins with a single step, and without that first step, the journey can never commence. First things first, we need to find a black hole that's close enough to visit. The nearest known black hole is about 1,565 light-years away, which is still too far for our current capabilities. But don't lose hope just yet. There could be black holes lurking much closer to home, just waiting to be discovered. Astronomers are getting better at spotting these elusive objects by observing the warping of space-time around them. Finding a nearby black hole within the next decade isn't out of the question. I believe we just need a bit of luck and have a black hole within 20 to 25 light-years, Bambi explained. If there's a black hole within that range, we can develop the technology for such a mission. If it's between 40 to 50 light-years, the technological requirements become more challenging. But if it's beyond that, I'm afraid we might have to throw in the towel. Once we've found our target, the next challenge is getting there. Bambi proposes a craft that can reach speeds up to a third of the speed of light. Initially powered by Earth-based lasers, then by solar or stellar power as it journeys to its destination. A trip that would take around 70 years. To gather the most data, Bambi suggests sending 2 or more probes to orbit the black hole. These probes could communicate with each other, allowing scientists to map their trajectories and study how electromagnetic signals behave in the warped space-time around the black hole. Now here's where things get really interesting. Any data sent back from the probe would take an additional 20 years to reach Earth, for a total mission duration of around a century. That's a long time to wait, but Bambi argues that the potential payoff is enormous. By observing deviations from general relativity's predictions, we could gain clues to develop a new theory that goes beyond Einstein's groundbreaking work. It may sound like science fiction, Bambi admits, but people once said we'd never detect gravitational waves because they're too weak. We did 100 years later. People thought we'd never observe the shadows of black holes. Now, 50 years later, we have images of 2. So what do you think? Is this the next giant leap for humankind, or a foolhardy mission that's doomed to fail? Should we be pouring resources into this audacious plan, or focusing on more practical, down-to-earth endeavors? The floor is yours. Let's hear your thoughts in the comments below. And remember, no idea is too crazy. No question too bold. After all, it's the bold questions that often lead to the most extraordinary discoveries.